Welcome to week 7 of Math 25. Today we will start the business decisions topic, but first some questions about old homework. We're looking at the last turn-in problem from the personal finance decisions saving for retirement. And it's an abstract doubling problem. So we've already seen, is that font big enough, by the way? How I pasted things on the Jamboard?
Yes.
Okay.
Yes.
So we've already seen the rule of 72 in general, and it looks like I didn't get the title, so let me write that on. So when I take the two numbers of the percent we're using, not riplopped, but just as a whole number, so 3, and I multiply it by how many years go by, or how many times an event increases by 3%, then that number is about 72, 3 times 24. Or as another case, if something increases 6% each time, how many increases would wind up doubling? About 12, because 6 times 12 is 72. Or a last example, if something went up 12% each time, it would only take 6 before they doubled, because 6 times 12 is 72. Normally, we don't have numbers that come up to 72 so exactly like that, but we could say if something goes up 10% each time, it takes about 7 times before it doubles, or so on. So that's called the rule of 72. And it's just sort of a summary of compound interest that might help you as an estimate. My friend and I are chatting while driving to the store about her retirement plans. Is she on track or not? Rough estimate. So here is a typical problem, 55. If you invest $1,000 in the account and it earns 2% interest each year, compounded annually, then how many years, how many of those 2% increases would it take before you double? So something times 2 is 72. 72 divided by 2 tells us it's 36, so it would take 36 years before you finally doubled your money. Notice that problem 55 doesn't care about the 1,000. That's a red herring. That's something that's just there to distract you. It's not really part of the problem. It doesn't matter if you started with $1,000 or $2,000 or $1 million. It would still take 36 years to double. When we're looking at the compound interest formula, let's see, where's the first time we see that? Yeah. Then what we're trying to do, it's not going to fit on that slide. Is get the second part about the same as 2. So that whatever the principal was, what we're multiplying it by is going to be 2. And that depends on the interest rate per payout, and it depends on how many times that payout happens. So if you had, going back to this chart, if you had a 3, or I'm sorry, a 0.03 here, it would be about a 24 as the exponent. That's just how it works out. When you plug in those two, then the whole right side becomes about a times 2. Alternately, if we had this being 0.06, then the top would be about 12. It just works out the way exponents go, that would make this whole thing about a times 2. And lastly, if we had a 0.12, then the exponent is about 6. And that would make this whole thing here about a times 2. And why those exponents have this pattern is not something I can explain in Math 25. We just have to trust that when the two numbers work out to multiply to 72, then that green highlight area of the compound interest rate simplifies to something that's about times 2. Does that make sense so far?
Yes.
So it doesn't matter what the principal is. This again is the red herring. Because the rule of 72 isn't about that part of the equation. It's just about the green highlight part of the equation. Okay, now we can talk about the homework problem. In a certain computer game, there's a thing, and again, it doesn't matter what this is. The fact there's a cute picture of an archer queen doesn't matter. Something in the world gets 10% bigger each time. So, how many times does it take before that doubles? Not 10. That would be simple interest where there's no compounding happening. What number times 10 is about 72?
That.
Yeah, if it gets bigger 7 times, it will roughly double. If I put a 0.1 here and a 7 in the exponent, 1.1 to the 7th will be about 2. Let's plug it in our calculators and check. If I put 1.1 exponent 7, they get 1.9487. So a little bit less, because it's less than 72, it's 70, but pretty close.
So you got 1.94871.
Mm-hmm. So again, whatever is getting 10% bigger each time, because it's 10% bigger each time, after 7 times, it will roughly double. So in this game, one player has something level 20. We don't know what that means. We don't care. Another player has had something get bigger 7 times. Compared to the level 20, this one has gone up 7 levels. So it's gotten 10% bigger 7 times, so that means it's twice as big. Right, so this happened. It got 10% bigger 7 times. Which is kind of remarkable. We know nothing about this computer game. We don't know how strong these things are in the game or anything. All we know is that something got 10% bigger 7 times. But that's enough to tell us it's twice as big as it used to be.
So is it 50?
If this sort of goes over your head, especially if you're just watching the video and don't have an opportunity to ask questions, then don't worry, it's not a crucial thing. It's much more important in Math 25 to be able to use the simple and compound and sum of annuity do formulas properly. But this is a useful time to skip using the formulas in real life, to just say, oh, so I'm talking to this relative at a family gathering, and they said that they're so happy they found this annuity that will guaranteed increase 3% a year. And you can say, well, that's going to take 24 years before you even double your money. Can that really help you retire?
That helped you.
Anything else with homework that people want me to do?
Second, David, I want
I'm sorry, what did you say, Donna?
to. I got to finish this problem really quick and.
Oh, okay, I'll go back to it.
I just want to verify on number one. We divide those two.
You're cutting in and out with your microphone. You want me to look up problem number 1?
So I believe that we take the 100 and divide it by 0.30. I was just checking.
Okay, so for Tom, our general formula for percent change is change divided by original. So in his case, the change is 30. The original is 100. And we get 0.3, which is 30%. For Eric, it is still true that percent change is change divided by original. So his change is 30 again, but his original is 200. So we divide that, we get 0.15. So 15%. Your math matches? How is it true that that they both went up the same dollar amount, but the percent change is different? Well, that's not surprising, because $30 is a bigger significant change when you start at 100 than when you start at 200. Good morning. We just did the last problem for the turn-in with the rule of 72 and doubling, and then we did the first problem. Did you have homework questions too? Okay, well, I'm going to move on then. So personal finance decisions was our second topic, and it was a little bit harder than the health decisions, which is why we're doing them in this order. The health decisions had lots of formulas, but they were all very different, whether it was for exercising or how many calories are in food or how to scale up recipes. There was never any confusion about which formula should I use, because the situations were all so clearly different. The formulas were also very different. In personal finance decision, then things got a little more tricky, because simple interest and compound interest and the sum of annuity due formulas resemble each other. They have the word principal in them, even though it means different things. It could mean just one initial amount of money that you just watch change, or it could mean, in the sum of annuity due formula, a repeated deposit every January. And the kinds of payouts were tricky. And sometimes you had to worry about adjusting from years to months. Other times you didn't. So the formulas were just a little confusing. They looked too much like each other, and the tricky parts of each formula didn't match up. So that's sort of where we went to with personal finance decisions. Now we're starting business decisions, and business decisions are in a way simpler. Unlike the personal finance decisions, we're not going to get mixed up. There's not things like simple and compound and sum of annuity due that look too similar to each other. So it is nice that things are clearer about what we're doing at each time. But we're talking much more about a process. The goal of these kinds of homework problems isn't just to pick which formula to use and plug things in carefully. Instead, there's usually a process that might involve a formula, but we're deciding how to price things or what kind of charge option plan to use or something. And so it's kind of a more honest word problem. Trying to figure out what's happening is the issue, not which of these formulas that looks too much like each other is the one to use. That being said, unfortunately, the way history has defined words in the English language, we will start by talking about margin and markup. And there are two formulas that are sort of similar there. They really aren't. It's just that the words in English are used poorly and sloppily by most of us. And so things look more similar than they are. So that's the kind of heads up as we're starting business decisions. Okay, there's an interesting picture here on how much markup or margin happens in different industries, but we're going to start a new topic with lots of careful vocabulary. That's not surprising. That's how we normally do things. And compared to what we've done before, I'm going to be just reading from the website a lot because it's the English language is the issue here. And I don't think me trying to improvise it as I am teaching will work as well with tricky words as writing what I've already thought about how to explain as clearly as I can. So let's get started. The word price isn't a word that we want to use without any adjective attached to it. Just like when we were doing some of the health topics, then there were things we wanted to be careful about our words, then this is true too. So we're always going to use an entire phrase, either a wholesale cost, this is what the business pays its supplier for the item, or a selling price, this is what the customer pays. Oops, there we go. I'm not sure why it's highlighting badly. Okay, there we go. Selling price, this is what the customer pays to the business. And that's not universally used. This is just, in Math 20, we're being as careful as we can. Wholesale cost and selling price. And the first other word we use is what's called a margin amount. So the difference between the selling price and the wholesale cost, we're going to call the margin amount. And we can think about it with a couple directions. So we have the selling price, which is going to be more. And we have the wholesale cost, which is less. And I'll write the wholesale cost under in this little diagram just because that means less, right? So we could say the margin amount is the selling price minus the wholesale cost. In other words, if I go down, how much I go down, we'll call the margin amount. Or we could think about the second formula. If I start at the wholesale cost and I go up by the margin amount, then I get to the selling price. So there's two formulas, one with a subtraction, one with an addition, and it's basically, am I just kind of starting up top and looking down, or am I starting down below and looking up? The goal is that if we put these together, we get to that one. Or if we start here and take away either of these, what's left is the other one. Okay, so just to make sure we're not asleep, Dora's Dress Shop can get an item for $60 wholesale cost. It sells it for $80 as a selling price. What's the margin amount?
20.
20, right? It's 80 minus 60. So nothing hard now. Subtracting is easy. I'm just throwing vocabulary at you. There was a great segue a moment ago about percent change, change divided by original. Thank you for that nice segue. And we will often talk about margin not as an amount, a dollar amount, but as a rate. So the margin rate is change divided by original. The change is the amount, and the original is the selling price. Notice that this arrow went both ways. We could pick which is the original. Are we focusing on what we're selling things to the customer at? Or are we focusing on what we're getting it from our suppliers at? And different businesses use one model or the other. But the businesses that use the phrase margin rate will always start at the selling price to the customer and go down. So to them, the original is the selling price. And if you're not used to that, if what makes sense to you, if you were a business owner, is that we should start at the wholesale cost, then just be patient. We will get to yours mindset in a moment. Okay, see if we can do it in our head again. Dora's Dress Shop can get an item for $60 at the wholesale cost and sell it at 80. That was a difference of 20. That was the margin amount. What's the margin rate? So what's going to be 20 divided by 80?
0.25, so 25.
25%. Yep. 20 over 80 is a quarter, so 25%. So no new math. We're just taking English words that business community has invented and we don't get to change them, and using them to subtract and add and do the percent change formula. So a lot of math, 20 and 25, is making things harder than it is. Don't make this harder than it is. No new math yet. Okay, number 3, another business uses a 40% margin rate. What's the margin amount for an item with a selling price of $300? And what would the wholesale cost of that item be? So let's actually do this one on the board because it's not quite as friendly for mental math as 20 over 80. And it often helps to kind of draw that little diagram I did. So the selling price is 300. If you're using the phrase margin rate, you look down, not up. It's a 40% margin rate. And I want to know 2 things. What the margin amount is as dollars, and what the wholesale price is. So using my formula, the margin rate is over here. The margin amount, we don't know. The selling price is 300. If I have something stuck onto my letter with divided by 300, how do I get the letter by itself?
Gotta divide on both sides.
There's already a divide.
Multiply on both sides.
Multiply by 300. I'm also going to take the 40% and riplop it and make it a 0.4. So I get $12. Did I do that right? It would be 120, isn't it? 0.4. Yes, I'm not that tired. Okay, so it goes down by 120. So how much is left?
$180.
180. If you've done these a lot, you'll notice that we're asking what is 40% of 300. Of means times. You don't have to write out all the formula stuff. You can just think 0.4 times 300. Okay, so that's the mindset of the people that start with a selling price and look down to the wholesale cost. Now we're going to switch things up. That same difference between the selling price and the wholesale cost has a second word. Not only is it called the margin amount, it's also called the markup amount. And this is, again, an artifact of history. It's the English language. We can't change it. Why is there another word for exactly the same thing? Who knows? So, trick question. Same dress shop, $60, $80. The markup amount is what?
20.
20. Again, it's the same thing, just different words. So this section of our lecture notes is only tricky because of the words. If you want to think about the markup rate, you are the kind of business that doesn't look down, but looks up. You're going to start at the wholesale cost, and you're going to go up to the selling price. So for you, original is wholesale cost. When we do change divided by original, instead of dividing by selling price, we're going to divide by the wholesale cost, because to you, that's what seems more original. So it's the same change divided by original, but which thing we're picking as original has changed. So if you grew up with parents who were small business owners and so on, then this would be very easy for you. You'd be used to the English language words. But if these formulas look confusing, then it's because we're not used to talking about margin and markup. We're not used to thinking in our brains that margin always has the selling price count as original, whereas markup always has the wholesale cost counting as original. It's not a math thing, it's a word thing. Okay, so same situation. Different problem. Let's do both, actually. I can't put them side to side. Oh well. Okay, so number 2 we did in our head earlier. So this one was a $20 change divided by the $80 original was 25%. And that used the selling price for here. Now we're going to think differently. It's still a $20 change, whether you call it a margin amount or a markup amount, it's still the same thing. But now it's, the wholesale cost that counts as original. So what's 20 over 60 going to be as a percentage? About
33.
Yeah. This is very much like what we did earlier about the two different changing of value of paintings. I'm very happy you picked this one as our segue. So the same change was a bigger percentage of the smaller amount. So if you are somebody that is running this exactly the same dress shop, exactly the same dress, would you say it's a 25% change or a 33% change? It depends on if you are looking from the selling price down or from the wholesale cost up. And that's okay. If it seems weird, it's because we haven't run two different kinds of businesses in our own personal history. Most people don't. But the business community has businesses that work both ways. And so there's two different ways of measuring things. Oh, okay. So we have four terms. We have margin amount and markup amount. Those are dollars, and they mean exactly the same thing. And then we have margin rate and markup rate, and those are percentages, and they mean different things because what they count as original is different. And your main goal for this part of your homework is to do a bunch of random problems and get straight in your head the four different words. Because once you do that, everything is easy. Division isn't hard. Subtraction isn't hard. Just as a note, there are some places, books, websites that will use other phrases to mean these four words. So I'm not going to talk about that because I don't want to put in your head the sounds that we're not going to use that don't work as well. But just kind of be careful. If you read other things, then it will be less clear sometimes. Okay. So the last word we want is profit. Businesses have lots of expenses other than the wholesale costs: payroll, insurance, rent, utilities, advertising, taxes, and so on. So just because there is margin or markup doesn't mean that that's actually all a gain. You also have to pay those other expenses. So we can imagine a kind of fake business. Did anyone else ever play the old lemonade stand game when they were little? So you can imagine a 5-year-old who's trying to run a business in front of his or her sidewalk and front yard. And the parents pay for all these other things. Oh yes, you can borrow a table, use our paper cups, and so on. So in that case, every time the kid earns 20 cents from a cup of lemonade, it's all profit. Whether you call it a margin amount or a markup amount, it's all profit because there's no other expenses to go on. But that's completely fake, right? Real businesses always have other expenses. So your profit is less than the margin amount or the markup amount, whichever thing you call it. And that's something that people are very sloppy about. In normal English speaking, especially with people that aren't business owners, they say, I looked it up in the Consumer Reports. This car has a selling price of this and a wholesale cost of that. So the dealer was making this kind of profit on it, pretending that markup amount, margin amount was profit when it's not, because profit is less than those. So that's the formulas. That's the vocabulary of margin and markup. Now let's talk about how this actually works. And as a side note, there's sort of tactics that people use for what prices go where. We have an interesting book in the class library called Priced to Influence, Sell, and Satisfy. So if you are interested in what prices to assign to things, maybe your best friend just got a job running a small business, then this is a book all about why do people set prices for $4.99 instead of $5 and things like that. All the psychology about pricing and how to adjust prices seasonally and so on. But that's not what we're talking about. We're not going to get into the details of specific kinds of businesses and how people's psychology works and so on. We're going to stay in the math class. But if you like that, take that from the classroom library. Okay, so we talked about markup and margin. Markup, those are the businesses, remember, that base their decisions on the wholesale suppliers. They start at the bottom number and move up. The wholesale cost was what they considered original. So they're focusing on the wholesale. Their concern is building relationships with their suppliers and having brand loyalties and acquiring goods inexpensively. And they are aware that their final selling prices matter. They need to keep competitive. So they would do things about prices and inventory or seasonal things to keep competitive. But they normally use a markup rate. What's an example you can think of as a business that focuses on the wholesale when thinking about prices?
Restaurant?
A restaurant, yes, many restaurants will have good relationships with the local farmers and other suppliers, and their job is to work on the wholesale side of things, right? They will trust that they can keep prices well enough and they don't have to match the selling price of the neighboring restaurant exactly. People will say, I like this brand of restaurant. I like this particular restaurant, right? I have some loyalty to it. Their quality is good. So they will focus on the wholesale side of things. We had what was called the 1+ trick for making things bigger, and we can use that for these businesses. So again, this is not something new. The other one was just the percent change formula. This is just the 1+ trick. Wearing new clothes. The wholesale cost of something is $50. We're going to use a 40% markup rate. So I can just make it 0.4 because 40% is 0.4. And then we have that 1 that goes in front. So same 1+ trick. And I got way too little sleep last night. I am embarrassed I have to do this. There we go, 70. So that's something you already know how to do. Take an amount, make it 40% bigger with the 1+ trick. The 1 in front means we don't have to get an answer of 20 and add the 50 back on as a second step. You've seen this before. Not all goods should be given the same percent increase. We're not talking too much about specific tactics. Again, use the class library if you want to learn about that. But it makes sense as for some general guidelines. If there's a higher volume of sales, you can give them a lower percent increase. You won't make as much profit on those items, but they will attract customers, build your brand loyalty, and you will still be somewhat profitable. If something is trendy, you can give them a higher percent increase while demand is high. There's also a general overhead all that stuff we talked about before of, you know, payroll and utilities and rent and stuff, and you need to spread that amount. But it's usually not smart to spread it out evenly among everything. So here's a kind of silly example. If a business said, I need to pay for all those other general overhead costs, let's just add $5 to everything. Then you can say 50% of 8 . And then add 5. A lot of that tool's final selling price is based on this decision to add 5. So people might not buy that as well. Or maybe they would, because these are the best selling tools. Who knows? Questions about any of that so far?
I'm looking at that problem. Wouldn't, I don't know, when you said 50% of 8, my mind automatically went to 4.
Right, and then I'm adding it back in to the 8.
Okay.
That's why there's the 1 plus
Right.
trick, so we don't have to add it in as a second step.
Right. Okay. Sorry. Thank you.
That's okay. Good question. Okay, so for most people, this 1 plus trick thinking is what makes the most sense to them. We're used to thinking kind of in a wholesale way. If it's not that way for you, that's fine. There's product maturity. Normally, when something is newly invented, it costs a whole lot. It takes many years for the factories to evolve and get more efficient and inexpensive to produce things. So we had this chart we looked at last time about how it took quite a while for, say, clothes washers to penetrate into society for a high percentage of households that have them, whereas microwaves really shot up quickly and the internet really shot up quickly. So that's something that also can cause some need for adaptation. So number 9, ask about this one next class if you want. I don't want to do it right now. But imagine where there's a home goods store that has 3 different models of pressure canners. The newer models would have more features. They might even be more reliable. So they have markups that are different amounts. And so for a particular one, for this particular newest model, what would the selling price be? There's a lot of red herrings in this problem. So this is sort of a test at home if you're getting confused when there's too many numbers, some you don't need. And you can always peek at your answer. Another part of a pricing strategy that's just very general and not really about psychology is called bundling. Consider a store that sells vegetables. I'm not sure why that's a link. It's the government. Okay, so conventional lettuce, conventional carrots, right? People buy lots of those. Grocery stores make almost no margin on those. People will just go to the next store and buy their carrots if your carrots are too expensive. Whereas organic spinach and organic kale, those are trendy. The stores sell much less of those, but they have a much greater margin amount. People might say, I really like the organic spinach at this store, not that one. And the stores know that they can have a good reputation and earn a little more money for having that good reputation. So if you are that store, a smart thing to do is to mix them, have a display with mixed greens, and then people that wouldn't normally spend the money on the organic spinach and kale are buying some because it's cheaper because you've mixed it with some of your conventional lettuce. So by giving options for customers to buy a mix of the negligible margin and high margin things, that's often a good strategy for the store. So let's do number 10. So we have the conventional romaine. So 10%, 70 cents. Why is it 1.1? We have the 10%. That becomes that one. And then this is the one from the formula. Everyone okay with that, even though the formula is not on that page? Okay, and then we have the organic spinach. And that's a 70% markup on $3.20 a pound. So whatever that is. Everyone okay with what I have on the board so far?
Yep.
Okay, so what did they actually ask? They're wondering how many pounds of lettuce must be sold to earn as much markup as 1 pound of spinach. So the numbers I really care about are this one and that one. How many 7 senses does it take to make $2.24? What kind of arithmetic am I doing for that?
Division.
Division.
The answer is 32. Or well, 0.32, whatever.
So this store has to sell 32 pounds of conventional romaine lettuce to have as much markup amount as 1 pound of organic spinach. And they might do that. There might be 32 pounds of the conventional lettuce sold. There might be a lot more going through the store of one than the other. Questions about this slide?
No, sir.
Okay. If you like business things, click on this link. Good, better, best is a very popular strategy. You'll see lots of things from food to cars where there's more models. And it's called good, better, best because 3 varieties is a good one. Too many choices tends to overwhelm people. But to say we'll give you a cheap thing if you don't want to spend a lot of money, and then there's 2 versions that have more features or are bigger or whatever. And that way, if you want more things, then yes, we'll take more of your money. But if you don't, then you can get the one that's merely good. Okay, so once again, this is kind of how most of our brains normally work if we haven't grown up with businesses. We think about the wholesale cost first, and then use the 1+ trick to go up. We're getting bigger by the markup amount. But there's the other half of the business world that likes the margin pricing. So we had the 1- trick also. This was where if something goes down 30%, we'll multiply by 0.7 because that's 100% minus 30%. That's 1 minus 0.3, so that's 0.7. So this is also not new math. We're starting at the selling price and we're going down to the wholesale cost. And we're looking at what percent we're going down. Maybe I should write a similar thing here. No, it doesn't fit. Oh, okay. So we'll do a nice example. Make it big enough to read. Okay. So the selling price for an item is 50. The margin rate is 40. So we're going to think about 1 minus 0.4 will be 0.6. So this store can only afford to stock that item if they can find a wholesaler that will sell it to them for 30. So margin pricing is for businesses that base their decisions on their competition. They know if they charge more than 50 for this item, someone will go to the other store instead. 50 is the most they can get away with when they're setting the price. And they know that they need a certain margin rate to stay profitable. They have to pay their employees and their rent and their utilities and everything. So they take the $50 that they are forced to think about by the competition, combine it with their margin rate, because they have to earn enough to be a good business, and they say, I'm going to go shopping. Let's look at the wholesaler options. Can I get this item for 30? And if they can stock it. And if they can't, then they can't stock it. So their primary concern is to monitor how their own selling prices compare to that of similar goods. Their inventory has weak brand loyalty. Customers will shop elsewhere if they see a better deal. They want to keep their selling prices as high as a tough market allows. And again, it's not all a one-sided thing. Just like the other style pays attention to competitors somewhat, then these ones know that building relationships with wholesale suppliers is important and brand loyalty is important. But they know they also just can't afford to focus on those most. That's kind of a luxury for them if they can get away with it. So the classic example of a margin pricing business is the vitamin stores that used to be around in the malls all the time. I don't know if they are anymore, but people would have zero brand loyalty. If my vitamins are cheaper at this other store, I will immediately switch. What's another example we can think of a store with margin pricing? No ideas?
I'm sorry, what was the question?
What's another example of a store that uses margin pricing?
I would say sporting goods.
That would make sense. Okay, so the same lessons happen differently from this mindset. First, consistency isn't a virtue. A store isn't going to use the same multiplier for every item in their inventory. Businesses that use margin pricing frequently use loss leaders to attract customers. When you go to the grocery store, we've all seen the mailers they send us from the grocery store and the large storefront displays, right? Let's get in and buy our milk and other things that everyone wants. And then once we're in the door, then they can actually earn some money on the things that aren't the loss leaders. One detail is there are a few people, not many, that will travel a lot and visit lots of stores in an outing to buy each thing on their list at the least expensive price. But these people don't provide much profit for any business, so the business people will just ignore them. We can't make them happy anyway, and even if we did, they wouldn't get us any money to speak of. So it's the more typical customer that margin pricing focuses on. So perhaps the most famous loss leader is Costco's chickens. So if you click on the link, you can get a whole news article about Costco's chickens. But they sell about 60 million chickens a year, and each chicken is about a 57-cent loss. So how much of a total loss are those sales? What kind of math do I do?
Multiply.
Multiply.
Fraction.
So we get 34,200,000.
That's how much they lose?
That's how much they lose every year to get people into Costco to buy their chickens, which is why they put them way in the back of the store.
Holy crap.
That's crazy.
That's insane.
But it works for them because they sell a lot. Every time someone buys one chicken, then they also buy other stuff. So
Man, I wish I could throw away 34 mil.
it's not throwing it away. It's again for brand loyalty and stuff.
Well,
Do you know anyone that wouldn't go to Costco less if they couldn't get the chicken?
Costco is pretty good.
So
We never get the chicken.
So more vocabulary, just what you want. So skim pricing is the polite word for kind of price gouging. When something is trendy, usually when it's new, then it costs more. And technology things, phones, PlayStations, and so on, are famous for this. So the selling price, here's time going this way. So the selling price starts out so expensive, only a few people get the first few production. And then there's like the skim price. Everyone goes out and gets their new phone. It's the new and hot thing. The price is high. And eventually, as the price goes down, remember that other image with dishwashers and internet and so on, there's what's called the penetration price. Most households that want this already have one, or they have something similar. The demand isn't extra high anymore because enough time has gone by. It's the old and boring thing. So the penetration price is lower than the skim price. And this picture makes it look like a smooth thing, but usually it is just steps. So one that was studied a lot was the PlayStation 3. Let's imagine, and this is just a made up number. I have no idea what the wholesale cost actually is. I tried and tried to find it, but couldn't. But let's just imagine the wholesale cost is 120. So the skim margin it was initially priced at 500 when Christmas time 2006, PlayStation 3 was the hot thing. They could afford to put a price tag of 500 on it. Later on, it was no longer the new hot thing, and so now they're only charging 180 for it. So the margin amount went from 300 back when it was the thing to only $60 if you go pick one up these days. So the question we're being asked is, if we divide the larger margin by the smaller one, we can find the percent of extra margin. So if we say 300 divided by 60,
Five.
so that doesn't, am I doing it backwards? 3, oh, it should be 380 because I'm subtracting wrong because I didn't get enough sleep. I didn't think it came out to a whole number.
Okay.
Okay, 380 divided by 60. So about 6 times as much margin. When things were new and hot. There can be pushback. Apple has several times had bad publicity because they tried to set a skim price that was outrageously high. And even the people that love Apple said, no, for your phones, you're charging that? What do you think? I'm made of money? We talked about bundling before. And if you are thinking about a margin mindset, you can still think about bundling. So maybe there is some electronic item that has lots of plugs and cords. And the plugs and cords will be advertised as the loss leader. Buy our expensive phone and we'll give you some extra things that stick into it. Or maybe they'll price the new thing to undercut the competition. Our phone is cheaper than the other store's exact same phone. If you're buying your new and trendy phone, buy it from us because it's cheaper. But it's also bundled with plugs and cords that cost more than usual, and you won't notice that because you're so excited. So here is one that I'm not doing in class. This one, number 14, is sort of your check at home for this section. Again, there's lots of words and numbers. You will actually use them all this time, but this can check at home if you're understanding things. Our time is almost up, but we're almost to the end of this. There's vocabulary called adaptive and dynamic pricing. And in the olden days, not too long ago, they were used interchangeably, but now they mean different things. Adaptive pricing is adaptive in real time. So if you've ever tried to shop for an airline ticket and kept checking that same website day after day for a week, you'll notice the price goes up. The airline websites pay attention and say, Timothy is thinking about going to the Bahamas. So let's raise the price a little bit because he's obviously interested in this. Dynamic pricing isn't based on what actually people are doing. It's based on a prediction of the customer behavior. So this picture here, the Sears website at the time this study was done kept prices the same. But Best Buy would raise them up at dinner time. Everyone who came home from work and did some online shopping would pay up to the Sears price, where they were trying to keep it cheaper than Sears during the day, so the people that weren't working would use them. And then Amazon had all sorts of things. They were just predicting all kinds of weirdness. So if you're interested in that, do number 15, but it's sort of a side topic, a minor detail. I don't want to do things. There's also something called A/B testing, where you sell multiple versions of an item in different places and don't tell anyone. Should we sell this new cookbook at $5 or $7? So on one side of the river in Portland, we'll sell it at 5. On the other side, we'll sell it at 7. We'll see which sells better, and whatever works out to make us more profit, we'll switch to that. And in some cases, A/B testing is legitimate, and in other cases, it's against the law. There's some details that business owners will care about, but you can just know the word. And that sort of wraps up our beginning of business decision math. We've talked about margin and markup as an amount, a dollar amount, and as a rate. And we've talked a lot about which kinds of businesses might care about one or the other, and how they have percent change formulas, and how they have the 1+ trick or the 1- trick. Because a lot of Math 25 students are in the culinary program, then we're going to focus on pricing entrees as a specific thing. Not because it really is that different, but just because that's what a lot of Math 25 students care about the most. So let's look at that. I'm not sure how much time we'll have to actually go into it. If you want to find the cost per plate, then there's 2 ways to do it. Well, at least 2 traditional ways that we'll talk about. Can you still read it when I shrink the font so it fits on the one line down here? Let me see if I can blow it up a little bit. So the thing that we called thinking about markup in the restaurant industry, they call the desired profit method. We have the 1+ trick over here. And then this is the new part that wasn't there before. So the formula starts out very familiar. We're going to take all the costs, stick them together. That's what we were calling the wholesale cost before. They've just been broken down into subcategories. And then we're going to multiply by the 1+ trick. And if we did that, we would get how much to sell this large amount of food for. Whether it's a giant pot of soup or an enormous casserole or something like that. But people don't go to a restaurant and order a whole vat of soup. So when we're done, we need to divide by the number of servings to see what price goes on the menu. Does that make sense?
Yes.
So this is just what we've been doing. This is what we've been calling a markup on wholesale cost. And then at the end, we say no one buys the entire lasagna. We're going to give them a quarter of it. Okay, so what does that turn into? 32 plus 60 plus 15, then times 1.1, and then divided by 4, and I'm getting, that doesn't seem right. Let's try again. No, I guess I did. That's an expensive item. So 29.43. Just a nicer restaurant than I usually go to. Oh, okay. Yep. Markup pricing. I should use the right word. This was called markup. Okay. The other way to do it is a scale factor called the food cost percentage method. And instead of breaking down all the costs, what's the labor, what's the food, what's everything else, some restaurants are just very predictable. They know that their food is always about 25% or of their total expenses. So they can use that scale factor backwards with division, like yield percent and things, to determine the per dish selling price. So same setup, but now we are not caring about the labor cost or the other cost. This restaurant just knows that the way their kitchen works, things are pretty predictable. The food is 30% of the total cost. So if we take the 32 and divide it by the 0.3, we would get about $107 to make this entire meal. As before, it serves 4, so we're going to do a divided by 4 at the end. I'm going to change the color of that. And we'll get 26.66. So this is more like the amortization table or yield percent, where we're using a scale factor to adjust a number. We'll do more examples of both of these, as well as everything else, when I see you next time, because one example of each won't be enough. These answers don't match, and that's okay, because these are two different businesses with different business models. The classic example of the food cost percentage method are fast food restaurants. Right? If you are working at McDonald's or other fast food places, then the cost per plate doesn't really depend on what the item is. It's just that your food is a certain percentage of how you price things, and all of the costs for payroll and rent and utilities and so on are kind of spread out pretty evenly over all of your items. Discount starts easy and gets tricky. I'm not going to try and squeeze that in a minute. So the last part of pricing is discount, and then we're done. So that was a lot in one class. We talked about margin and markup and the 4 different phrases: margin amount, markup amount, margin rate, markup rate. And we talked about how profit is not any of them. And then we did most of the pricing section. So since we went too fast, we're going to spend a lot of time next class doing example problems. So we'll look in the personal finance, in the business decisions, and not only the turn-in ones, but the random ones also. We'll see what there is. So try these, the random 3 problems for margin and markup, and try those, the random 6 problems for pricing, and see what questions you have. And if you don't have enough questions, I'm just going to generate a bunch of problems and we'll do them together on next class. Okay, thank you very much. I'm going to stop the recording in case people have questions about their own homeworks or grades or things.